Hello, fabulous chemistry students. So this is your assignment 1.5, read aloud. If you are needing that extra support to have this read aloud, feel free to follow along as I'm reading through this article. You may also put it at your own speed. You can slow it down, you can speed it up, however you can in order to access the content. So you have already hopefully clicked on here. This is 13.1 because that is what CK12 has, but it says 13.1 Kinetic Molecular Theory. This is from Flexbooks 2.0 from the CK12 Chemistry for High School, Kinetic Molecular Theory. How much oxygen is in this container? Approximately 20% of the atmosphere is oxygen. This gas is essential for life. In environments where oxygen is in low supply, it can be provided from a tank. Since gases are very compressible, a large amount of oxygen can be stored in a relatively small container. When it is released, the volume expands and the pressure decreases. The gas is then available for breathing under normal pressure. The kinetic molecular theory. The kinetic molecular theory is a theory that explains the states of matter and is based on the idea that matter is composed of tiny particles that are always in motion. The theory helps explain observable properties and behaviors of solids, liquids, and gases. However, the theory is most easily understood as it applies to gases, and it is with gases that we will begin our detailed study. The story applies specifically to a model of a gas called an ideal gas. An ideal gas is an imaginary gas whose behavior perfectly fits all the assumptions of the kinetic molecular theory. In reality, gases are not ideal, but are very close to being so under most everyday conditions. The kinetic molecular theory, as it applies to gases, has 5 basic assumptions. Gases consist of very large numbers of tiny spherical particles that are far apart from one another compared to their size. The particles of a gas may be either atoms or molecules. The distance between the particles of such a gas is much, much greater than the distance between the particles of a liquid or a solid. Most of the volume of a gas, therefore, is composed of the empty space between the particles. In fact, the volume of the particles themselves is considered to be insignificant compared to the volume of the empty space. Number 2, gas particles are in a constant rapid motion in random directions. The fast motion of particles gives them a relatively large amount of kinetic energy. Recall that kinetic energy is the energy that an object possesses because of its motion. The particles of a gas move in a straight line motion until they collide with another particle or with one of the walls of its container. Number 3, collisions between gas particles and between particles and the container walls are elastic collisions. An elastic collision is one in which there are no overall loss of kinetic energy. Kinetic energy may be transferred from one particle to another during an elastic collision, but there is no change to the total energy of the colliding particles. Number 4, there are no forces of attraction or repulsion between gas particles. Attractive forces are responsible for particles of a real gas condensing together to form a liquid. It is assumed that the particles of an ideal gas have no such attractive forces. The motion of each particle is completely independent of the motion of all other particles. Number 5, the average kinetic energy of gas particles is dependent upon the temperature of the gas. As the temperature of a sample of gas is increased, the speeds of the particles are increased. This results in an increase in kinetic energy of the particles. Not all particles of the gas in a sample have the same speed, so they do not have the same kinetic energy. The temperature of a gas is proportional to the average kinetic energy of the gas particles. And there's a diagram right here. And underneath the diagram it says, gas particles are in random straight line motion according to the kinetic molecular theory. The space between the particles is very large compared to the particle size. Then there's a video here you can watch in order to kind of get engaged in doing the practice. Scrolling down to the summary. The summary states, assumptions of the kinetic molecular theory. Gases consist of very large numbers of tiny spherical particles that are far apart from one another compared to their size. Gas particles are in constant rapid motion in random directions. Collisions between gas particles and between particles and the container walls are elastic collisions. There are no forces of attraction or repulsion between gas particles. The average kinetic energy of gas particles is dependent upon the temperature of the gas. Quick review, things to think about before you start that practice is describe the motion of gas particles, what kind of collisions occur, and what is the relationship between kinetic energy of gas particles and the temperature of the gas. If you have not already started to do the continue practice, go ahead and get started on that.